In this video here, we're going to take a look at expressions relating to the roots of a polynomial. Now, in the previous videos within this chapter, we've had a look in detail at the roots of a quadratic, cubic, and quartic equation. And what we want to do now is summarize the expressions relating to the roots of these polynomials. So what I'd recommend here then is before watching this video, just go back and watch the previous 3 videos if you haven't already. So let's get started then with our first set of expressions here. So let's get started then with the rules for reciprocals here. So starting off then, we have quadratics here. So if we want to know the value then of this here, so 1 over alpha plus 1 over beta, that is equal to this fraction here of alpha plus beta over alpha beta. Nice and straightforward there to get us started. Then for cubics here, so if we want to know the value of 1 over alpha plus 1 over beta plus 1 over gamma, that is equal to this fraction here. So we have alpha beta plus beta gamma plus gamma alpha all over alpha beta gamma there. And then finally here for quartics, so if we want to know the value then of 1 over alpha plus 1 over beta plus 1 over gamma plus 1 over delta, that is equal to this fraction here. So what do we have then? Well, we've got alpha beta gamma plus alpha beta delta plus alpha gamma delta plus beta gamma delta there. And that's all over alpha beta gamma delta there. So that gives everything that we need here then for the rules for reciprocals. Let's take a look now at the rules here for products of powers. So again, just starting off with quadratics here, what do we have? So if we want to know the value then of alpha to the power of n times by beta to the power of n, we can rewrite this here as alpha beta all to the power of n here. So just basic rules of indices, right? So hopefully nice and straightforward here to remember. So now let's move on to cubics here. So if we want to know the value then of alpha to the power of n times by beta to the power of n times by gamma to the power of n, again, we can just rewrite this here as alpha beta gamma all to the power of n here. And then finally here for quartics, if we want to know the value of alpha to the power of n times by beta to the power of n times by gamma to the power of n times by delta to the power of n, again, we can just rewrite this here as alpha beta gamma delta all to the power of n there. So that gives us everything that we need here then for the rules for products of powers. Moving on then, let's take a look here at the rules for sums of squares. So again, just starting off with quadratics here, what do we have? So if we want to know the value then of alpha squared plus beta squared here, that is equal to alpha plus beta all squared minus 2 alpha beta there. So again, just a nice straightforward result to get us started. Moving on to cubics here then, so if we want to know the value of alpha squared plus gamma squared here, that is equal to alpha plus beta plus gamma all squared. We then subtract 2 lots here of alpha beta plus beta gamma plus gamma alpha. And then finally here for quartics, so if we want to know the value then of alpha squared plus beta squared plus gamma squared plus delta squared here, that is equal to alpha plus beta plus gamma plus delta all squared. And then we subtract 2 lots here of alpha beta plus beta gamma plus gamma alpha plus alpha delta plus beta delta plus gamma delta there. So that gives us everything that we need here then for the rules for sums of squares. And then finally here we arrive at the very last rule then, and this is the rules for sums of cubes here. So again, we just begin with quadratics here. So as we can see then, if we want to know the value of alpha cubed here plus beta cubed, that is equal to alpha plus beta all cubed minus 3 alpha beta times alpha plus beta. Moving on to cubics then. So if we want to know the value of alpha cubed plus beta cubed plus gamma cubed here, that is equal to this expression here. So what do we have then? I've got alpha plus beta plus gamma all cubed. We then subtract 3 lots here of alpha plus beta plus gamma. We times that by alpha beta plus beta gamma plus gamma alpha. And then we add 3 lots of alpha beta gamma there. So you might be thinking we're missing quartics here. But the good news is for the rules for sums of cubes, we don't need to know the expression here for quartics. Okay? So that gives everything that we need here then for the rules for sums of cubes. And that gives everything that we need here then for our introduction to expressions relating to the roots of a polynomial. So let's take a look then at some practice questions here. Let's get started here then with question 1. So what do we have here for question 1? Well, as we can see then, we're given this cubic equation here, and we're told that it has the roots alpha, beta, and gamma. So for the first part of this question then, part A, it asks us to write down the value of the following here. So what do we have then? I've got alpha plus beta plus gamma, alpha beta plus beta gamma plus gamma alpha, and then finally alpha beta gamma here. So these expressions then in part A are just part of the standard results here for the roots of a polynomial. So for part A then, Starting off here with alpha plus beta plus gamma. So alpha plus beta plus gamma. So this expression then is equal here to minus b over a. Okay. So going back to this cubic equation here then, let's just obtain the coefficients here. So a is equal to 1 here. B is equal to minus 4. C is equal to 6 here. And then finally D is equal to 5. Okay. So in that case then, the value here of alpha plus beta plus gamma is equal to minus b over a. So in that case then we get minus here, minus 4 over 1. So minus 4 over 1 here. Well, in that case then, minus of a minus here becomes positive. So we get 4 over 1, which is the same as 4 there. Okay, so nice and straightforward there just to get us started. So for the second expression here, then we have alpha beta plus beta gamma plus gamma alpha. So alpha beta plus beta gamma plus gamma alpha here. So this result here then, this is equal to C over A. So in that case then, what do we get here? Well, C is equal to 6, A is equal to 1. So we get 6 over 1, which is the same as 6 there. Okay, so again, nice and straightforward here. And then finally here we have alpha beta gamma. So alpha beta gamma here. Alpha beta gamma, again, it's one of our standard results here. This is equal to minus D over A. Okay, so in that case then, what do we get here? So I get minus, D is equal to 5, so I get minus 5 over A, which is 1. So minus 5 over 1, that gives us minus 5 there. Okay, and there we have it. So nice and straightforward. That gives us the solution there to part A. Now for part B then, it says, hence, find the value of the following here. So we've got these three expressions here then. So let's start with the first part then. So this is B part 1. So for B part 1 here, we have this result, or this expression I should say. So I've got 1 over alpha. So 1 over alpha plus 1 over beta plus 1 over gamma. Okay. So to obtain the value here of this expression then, we need a fraction here. So what I need then for my fraction here is this expression divided by this expression here. So nice and straightforward then. So I've got alpha beta plus beta gamma plus gamma alpha. And this is all over then alpha beta gamma. So that's all over alpha beta gamma. Well, in that case then, we know the value here of this expression, that's 6. We know the value of this expression here, that's minus 5. So I get 6 over minus 5 then, which is the same as minus 6 over 5 there. Okay, and there we have it. So that is the solution to the first part of B. Now for the second part of B here, we have alpha squared plus beta squared plus gamma squared. So for the second part here then, we have alpha squared plus beta squared plus gamma squared. Okay. So to obtain the value of this here then, well, the result that we need is alpha plus beta plus gamma all squared. And then we subtract 2 lots here of this expression, right? So 2 lots of alpha beta plus beta gamma plus gamma alpha. So let's just write that down. So alpha beta plus beta gamma plus gamma alpha here. Okay. So in that case then, what do we get here? Well, alpha plus beta plus gamma, that's 4. So I get 4 squared minus then 2 times this expression here, which is equal to 6. So I get 2 times 6 here. So what have I got then? Well, I've got 16 minus 12. So 16 minus 12 here, and that gives us 4 then. Okay, so there we have it. So that's the solution to the second part of B. And then finally here for the very last part of B here, we have, so what do we have then? So I've got alpha cubed plus beta cubed plus gamma cubed. So let's just write this down here. So alpha cubed plus beta cubed plus gamma cubed. Okay. So for this expression here then, to find the value of this expression anyway, we need the following result here. So this is alpha plus beta plus gamma all cubed. So then we subtract 3 lots here, so minus 3 times alpha plus beta plus gamma. And then we times this here by this expression, right? So we times this by alpha beta plus beta gamma. And then finally plus gamma alpha. Okay. So altogether then, what do we have here? So alpha plus beta plus gamma. We know the value of this expression here. That's 4. So I've got 4 cubed. So 4 cubed here. Minus 3 times this here, which is 4. So 3 times by 4. And we times this here by this expression then, which we know is equal to 6. So putting all of this together here then, we have 4 cubed, which is 64. I then got 3 times 4 times by 6 here. So what would that give me? Oops, I'm also missing something. I'm also missing the 3 alpha beta here, so don't forget that. There we go. I knew I was missing something. Okay, so like so. So in that case then, 3 lots of alpha beta gamma here. So alpha beta gamma is equal to minus 5. So I've then got plus 3 times minus 5. Okay, I knew something was missing there. I was just wondering where it had gone. So there we have it. So 3 times 4 times 6, that gives me minus 72 there. So minus 72, and then 3 times minus 5 gives me minus 15. So I've got 64 minus 72 minus 15 here. So if we evaluate this, we get minus 23 then. Okay, and there we have it. So that gives us the solution to part B. Apologies for this little error here that I nearly missed. So don't forget the 3 alpha beta gamma there. So I did 3 times minus 5 there, just what we were missing. But once you evaluate all of this here, we get minus 23, right? Okay, so there we have it. So that gives us the solution there to question 1. So to finish with here then, let's just take a look at one more question. So what are we given here for the very last question? Well, as we can see then, we're given this quadratic equation here, which has the roots alpha, beta, gamma, and delta. Now for the first part of this question, then part A, it just asks us to write down the value of the following expressions here. So very similar to the previous question, but just notice now for this question here, we are using the alternative notation then. So sigma alpha beta, sigma alpha beta gamma, and then finally alpha beta gamma delta here. So for part A then, using the alternative notation here, so starting off then we have sigma alpha. So for sigma alpha here, this is one of our standard results then, and this is equal to minus b over a. Okay, and what we need here then is the coefficients of this quadratic equation here. So in that case then, a is equal to 1, b is equal to 2, c in this case, we'll just be careful here, is 0. We have no x squared term. So c is 0, d is equal to minus 3, and then finally e here is equal to 8. Okay, so in that case then for sigma alpha here, that is equal to minus b here, which is 2, over a, which is 1. So we get minus 2 over 1 there, which would give us minus 2 here. Okay, nice and straightforward there to get us started. So now for sigma alpha beta here, this is equal then to c over a. Okay, well c here is 0 over a, which is 1. So 0 over 1 would give us 0 there. Okay, for the third expression here then, so this is for sigma alpha beta gamma here. Well, that is equal then, in this case, to minus d over a. So minus d over a. So minus d over a then, what do we get here? So I get minus 3 over 1. So minus 3 over 1, which if we just take care with the signs here, would give us positive 3 here. Okay, and then finally we have alpha, beta, gamma, delta. So alpha, beta, gamma, delta here. This is equal then, again, this is just one of our standard results. This is equal to e over a. Okay, which in this case then gives us 8 over 1 here, which simplifies to give us 8 there. And there we have it. So that is the solution there to the first part of this question, then part A. So now for the second part of this question, then part B, what do we have here? Well, very similar to the previous question then, it just says hence find the value of the following expressions here. So to get us started then with part B, we have 1 over alpha plus 1 over beta plus 1 over gamma plus 1 over delta. So let's just start by writing this down then. So we have 1 over alpha plus 1 over beta plus 1 over gamma plus 1 over delta. Okay. So given that we use the alternative notation here in part A, I think it makes sense to also use the alternative notation then for part B here. So again, this will give us a fraction here. So for the numerator then, that will be this expression here. So sigma alpha beta gamma. So we get sigma alpha beta gamma here. And this is all over then alpha beta gamma delta here. So alpha beta gamma delta. Well, we know the value of both of these expressions here then. So for the numerator, that's equal to 3. Then for the denominator here, that's equal to 8. So we get 3 over 8 there for the first part of part B. So for the second part, then it wants us to find the value of this expression here then. So we have alpha squared plus beta squared plus gamma squared plus delta squared. So for the second part then, let's just write this down here. So we have alpha squared plus beta squared plus gamma squared, and then finally plus delta squared here. Okay. So again, just using the alternative notation here then, what would this be? Well, this would be sigma alpha squared. So sigma alpha squared minus 2 lots then. So minus 2 lots here of sigma alpha beta. Okay. So if we evaluate this here then, what would we get? Well, sigma alpha squared. So we know the value of sigma alpha here. That's minus 2. So I get minus 2 squared. We then minus 2 lots here of sigma alpha beta. Well, sigma alpha beta is 0. So minus 2 lots of 0 here, which would obviously just be 0, but we'll write it down anyway. So in that case then, minus 2 squared is 4. Minus 0 there. That would give us 4. Okay. And then finally here for the very last part, then we have alpha squared times beta squared times gamma squared times delta squared. So nice and straightforward here to finish with then for part B. So all we need to do here is just rewrite this using the rules of indices then. So alpha squared, beta squared, gamma squared times delta squared. We can rewrite this here as, so we can rewrite this as alpha, beta, gamma, delta, all squared here. Well, we know the value of this expression here then, that is 8. So we get 8 squared here, which is equal to 64, right? And there we have it. So as you can see then, these questions here, I don't think are really, too challenging, but it's just being aware of kind of the notation that we use here, especially this alternative notation. Okay, so as you can see then, this can come up for exam style questions. So there we have it. So that gives us the solution there to the very last question, question 2. And that brings us to the end then of this video here on expressions relating to the roots of a polynomial.